So now we're going to move on to the determination of the relation between the sides of a triangle and the median by the theorem of Apollonius. So let me actually draw this triangle easily. So this is the triangle, this is the median. These are the three medians basically. It has three medians. So now the sides are the opposite side of vertex A is A. So A, B, C. So B is this, C is this, D is this thing, that is AD. This is AD. So AD is D. Let me use a different ink. So this is D. This is, which one is E? So this is E and this is F. Okay. Now we need to actually create a relation between the sides of a triangle, the length of sides of a triangle, and the length of medians of a triangle. So to find the relationship between each side, what we're gonna do is use the theorem of Apollonius. So Apollonius told that AB square plus AC square is equal to the median AD square plus BD square, that is this smaller part, this part, and multiplied by 2. So AB square can be written as C. So C square plus AC square can be written as B is equal to, and AD can be written as D. So 2D square, and that BD, the total of BC, that this thing total is A, and BD is half of A. That means length of BD is basically A by 2. So A by 2 square. Okay. So third bracket is better to be used. Changing to red. So now we get 2D square plus 2 into A square by 4. That means we get 2D square plus A square by 2. Okay. So now if we actually want to create if you want to move this side here, and these we're going to move these parts on the right side. So we get C square plus B square minus A square by 2 is equal to 2D square. So now if I actually divide this, simplify it first. So 2C square plus 2B square minus A square divided by 2. Okay. Now we have 2D square. So therefore D square is equal to, we can write what we can write. We can write 2 square is 2D square plus 2C square minus A square divided by 4. Or it can be written in this way, 2B square plus C square minus A square by 4. Okay, so we've actually created a relationship between the sides of a triangle and the length of the median. Okay, so D is the median, and we got 2 into B square plus C square minus A square divided by 4. Similarly, if we want to find the area of other medians, so E square will be 2 into C square plus A square minus B square divided by 4. Okay, so let us actually try to find a common theme here first before writing this, because B is on this side, C is on this side. But now in case of E, so E is here, we get A and C. So I will written the right thing, and B is the side housing the median, that is the side in which we are using the median to split it into half. Okay, so this is how it is written, and F square will be A square plus B square multiplied by 2 minus C square divided by 4. So these are the basics of finding the relationship between the sides and the medians of a triangle. So median, it can be written as median square equal to 2 into sum of opposite square minus a base square, that is, let me write it, base square divided by 4. The sum of opposite, why I am telling you sum of opposite, because if you see the line AD, it's not directly called AD. So AD, the opposite side is AD is AB and AC. So these are opposite to AB and AC. So if I take this as AD and AC is here and AB is here, okay. So I call them sum of opposite side. If you want to call them different thing, so it's up to you. Or you can call them the sides originating from the same vertex, because see, they are actually originating from the vertex A. Okay. So you can write the sum of the sides originating from the same vertex as the median, and squaring them, each of them, and then minus base. That is, base is the line or the flat surface on which the median is staying or landing and intersecting and dividing into two parts, and then we divide it by 4 and we get the median square, that is length of the median, squared value of the length of the median. So this is the basic of finding the relationship between the sides of a triangle and median by theorem of Apollonius. Okay, now in the next part, if we add all of those values of our median, so b square plus e square plus f square, we see a common pattern. So 2 plus b square plus c square minus a square divided by 4 minus 2 c square plus a square minus b square divided by 4, plus, and finally plus 2 a square plus b square minus c square divided by 4. Okay, so now if I add them, so 4 will be the common LCM. So 2 b square plus c square, okay, 2b plus c square plus c square plus a square. Okay, let me write it in different order for your betterment, because I know I can write it shorter, but if I do that for you, you might get confused. So 2b square plus 2c square, that is expanding these two, okay, then minus a square, plus again expanding these two, 2c square plus 2a square minus b square, plus 2 into a square plus 2 into b square, plus 2 into a square plus 2 into b square. Okay, and then finally minus c square. Now see what we can cancel out from here. We get, let me shorten them first. So we get 4a square plus 4b square plus 4c square, and minus a square minus b square minus c square divided by 4. And what we see that on the top we get 3a square plus 3b square plus 3c square, because cancelling a square, 1a square from 4a square will give us 3a square. Similarly, 4b square minus b square is 3b square, 4c square minus c square is 3c square divided by 4. And if I take common 3, a square plus b square plus c square divided by 4. So I got that summation of these mediums square, the summation of squares of mediums is equal to 3 by 4 of the summation of square on the length of the sides. And you can use it in various maths, especially I guess in the seventh math of exercise you might need to use it. And this is one part. And so we can say that in a triangle, the thrice of the sum of the area of a square is drawn on the three sides or is equal to the okay, not gonna read that. Basically what I told was summation of squares on the mediums, so d square plus e square plus f square is basically equal to 3 by 4 into a square plus b square plus c square, that is 3 by 4 into the summation of squares on the length of sides. Okay, so now if I move on to another part, in that case it is a right angle triangle. So right angle triangle. Now if I draw medians from here, okay, okay, drawing the medians with different line would make it look beautiful. Okay, and okay, sorry. So this, okay. So now if it is a right angle triangle A, B, C, and this is okay, use a red pen, D, E, F. So this is A, this is C, and this is B. Now in a right angle triangle, we know that B square is equal to C square plus A square. Now if I add another B square, we get 2B square equal to B square plus C square plus A square. Okay, so initially it was B square equal to C square plus A square. Basically this is the B is the hypotenuse, length of the hypotenuse, C and A are the length of the other two sides. So the summation of the squares of other two sides will be equal to the length of the hypotenuse squares. Okay, now B square plus C square A square is equal to the length of the squares drawn on the length of the area of the squares drawn on the three sides of the right angle triangle. So in the previous part we learned that B square plus E square plus F square was equal to 3/4 A square plus B square plus C square. So basically A square plus B square plus C square will be 4/3 A square plus B square plus C square. Okay, basically if you move this on the left side, we get 4/3 into this is equal to this. So we can write it here. So 4/3. So 4/3 dot B square plus E square plus F square. Okay, finally these 4 and these 2 can be cancelled out and we get 2. So we get 3B square is equal to 2/2 D square plus E square plus F square, or you can write it in this way also. B square is equal to 2/3 D square plus A square plus F square. Okay, so what this means, the area of the square drawn on the hypotenuse of a right angle triangle is 2/3 of the summation of area of squares drawn on the median on the three medians, that is D square plus E square plus F square is the summation of area of squares drawn on the median D, then median E and median A, and the total area will be 2/3 of the area of the square drawn on the hypotenuse, that is B square. Or we can use this, therefore we can say that twice the sum of the area of the squares drawn on the medians of right angle triangle is equal to thrice the area of the square drawn on the hypotenuse, that is this line. It means 3 times the area of squares drawn on the hypotenuse is equal to twice the area of the squares drawn on the medians, and this is only applicable in case of a right angle triangle. Okay, so that is with that I guess we have solved everything we need to actually move on to exercise 3.1. So we are going to move on to the exercise 3.1. Okay.